a bit. There we go. All right, so today it's kind of like a two-part lesson today, both at 9 o'clock and 10:30 because they're so highly related. Well, they're not highly related. 10:30 today is going to be like part two of what we're doing today, which is something you've never seen before. We're going to do something called completing the square. I'm going to explain what that means and how we're going to do that. The key here is that we've looked at quadratic equations in two forms so far. We've looked at vertex form, which is the y equals a times x minus h squared plus k. And we've also looked at vertex form, which is y equals ax squared plus bx plus c, which is standard form. Now, the thing is that you have to be able to go from one form to another, converting them or changing them, an equation from standard form to vertex form or from vertex form to standard form. And the reason for that is that these equations have pros and cons. Vertex form here, we graph that, very easy to graph. Standard form, now if we were in regular school, we would have graphed it, not fun, not fun. We didn't do that. Solving, factoring, we can solve a quadratic equation in standard form by factoring, which we've done quite a bit. And vertex form, that's where we use square roots. So again, they have different applications of why, pros and cons of why you would want an equation in one form and why you would want an equation in another form. Now, what we're going to look at today is moving them from form to form, specifically for moving from standard form to vertex form. And we're going to use this process called completing the square to make that happen. Now, and again, at 10:30 today, we're going to look at why we need that specifically. Now, to start off, I'm going to look at something that's in vertex form and convert it to standard form. And then we're going to focus on the other one. Now, the reason that converting from vertex form to standard form is a little bit easier is because it's something we've already done. Is that I have an equation here, y equals x plus 4 squared. I'm just rewriting the equation here, plus 3. Now, this binomial square here is something that we've done before. And so what I could look at is I could write that x plus 4 squared as x plus 4 times x plus 4. And of course, I have this plus 3 on the side. And again, this is what we did in day 1 of unit 3, which is in this unit, which will be on our test. We use FOIL. This is before the break, where I multiply the first one. So I better put my y equals here. We'll multiply our first one. So x times x, that's x squared. Then we go the outside one. So that's x times 4, which is a 4x. Then we have the inside one. So we have a 4 and an x. So 4 times x is another 4x. And then, of course, the last one's 4 times 4, which is 16. And then, of course, I can't forget this plus 3. And then simply what I'm going to do is collect like terms. So I have x squared, that's the only x squared term here. I can put my x's together, so 4x plus 4x is an 8x, and my numbers together to get 19. So converting from standard form from vertex form to standard form, nothing too special there because all we use is FOIL, collect like terms, and we've changed it into the standard form. Now it's going back the other way. That's much tougher, and that's called completing the square. So that's what we're going to do right now. All right, so let's see here. All right, so let's get rid of these. Now, what I'm going to do is, we'll start off here. Example 2 is now we're going to convert. Change up my note here. I guess I won't change up my note here. Convert y equals x squared plus 8x plus 13 to vertex form. All right. So again, we're going to do something called completing the square. Now, here's, and again, this takes a little bit of practice to get used to and see what I'm doing. All right, so the first example, if you don't understand what I'm doing, hold on, all right? I'm going to do a few of them, and then we'll kind of get the idea of what the heck is happening here. Now, in the end, again, I'm going to take this equation here, y equals x squared plus 8x plus 13. And my goal here is to make it look like this. Y equals a times x minus h squared plus k. That's my whole goal here. Now, this whole completing the square part is all about creating this x minus h squared part. That's the whole deal with completing the square. And so what happens here is I'm going to put this x squared plus 8x in brackets. All right, now, and I've got this positive 13 over here. Now, what somebody noticed is that if I put a particular number here, I can change what I have in brackets here to make it look like the x minus h squared part. And what they did was the specific number that I need here is I take this 8, and the first thing I do is I cut it in half. All right, so I take 8 divided by 2, I get a 4. But then what I have to do is then take that 4 and square it. So I take that 4, I square it, I get 16. So that is kind of like the magic number that I need to put right here in brackets. Again, takes a few of these to understand what I'm doing. All right, so I'm going to put a plus 16 here because that's the number I need here to complete the square, as they say. Now, I can't just randomly throw a 16 into the equation, right? That changes the equation. So what I have to do is, so that I'm not changing the equation, I'm just changing the way it looks. That's all we're doing here, changing the way it looks. I put a plus 16 here. Well, outside the brackets, to balance things out, I'm going to put a minus 16. All right? Now, here's what somebody noticed. I have no idea how they noticed this stuff, but back in the day before PlayStations and cell phones, they did. Now, what they noticed is if I have a pattern here where I take half of this number and then I square it, and if that number's right there, I can rewrite this part in brackets as a binomial squared, as it's called. I can make it look like the x minus h part. And what happens is, well, there is going to be an x here. But then, the number that goes inside the brackets, again, I look at this 8x, or 8, and I just take half of it. And so it would be a plus 4. And the reason is that if I take this x plus 4 squared, which again was x plus 4 times x plus 4, and I do FOIL, I get this thing in brackets, right? So I take this, do FOIL, I get this thing in brackets. That's what somebody noticed. So all I'm doing here is changing the way this part looks. They are equal to each other. They just look different, which is a word for that in math is equivalent. All right, so these two are equivalent. They are the same. They look different. It's just like 1/2 is equal to 0.5. Same thing, look different. But then I have this stuff over here. This is just kind of the leftover numbers at the end. And so if I have a minus 16 plus 13, that is a minus 3. And there again, now our equation is in vertex form, where I have y equals, there is actually a secret one here. There's our a value, there's our h, and there's our k. All right, so again, I'm going to have to do a couple of those so you get the hint of what I'm doing here. All right, so here we go. All right, so next up, example 3. Sure, yeah, nice and. All right, so I'm going to convert y equals x squared plus 6x minus 4 to vertex form. All right, so here we go. I got y equals, I'm going to put the x squared plus 6x in these brackets, all right? Because I'm going to tell you what, minus 4 is not the number, the magic number that we need. So I'm going to put it over here in the end. There it is. Now, here's what we do. We find out again that number that we need to complete the square, complete the pattern, make them equivalent. All right, so again, what I do is I look at this 6, the number in front of the x, it's a positive 6. All right, I cut it in half. So I got 6 divided by 2. And I got a 3. And then the second step is I take that 3 and I square it. And so 3 squared is 9. All right, so that's the number I need. So I put a plus 9 right here. But again, I can't just randomly throw a 9 in. I have to balance things out. So when I put a plus 9 in, on the outside here, I got a minus 9. All right, now, what I can write is that part in round brackets now is going to be written as the x minus h squared part. All right, so it's going to look like a binomial squared. Again, they're equivalent, which means they are the same, but look different. So again, there's an x here. And then I got to figure out what number's here. Well, again, I look at the 6. I just take half of it, and it's a positive 3. So that's what goes in the brackets there, an x plus 3. Again, it's half of 6. And then again, I have the leftover numbers here. I have a minus 9, minus 4. That's just the leftover stuff I have to figure out. Well, minus 9, I lose 9, I lose 4. I'm down 13. Now it is in vertex form. All right, let's do one more of those and then try something else here. Step it up, I guess. All right, so the next one here is example 4. We have y equals x squared plus 10x minus 10. All right, so again, I'm going to convert this to vertex form. All right, so again, I'm going to write it out here, but I'm going to put the x squared plus 10x part in round brackets. Now, minus 10 is not that number we need, that magic number. So anybody could tell me what the magic number is, the number I need to put right here.
25.
25, let's see. So you took half of 10, which is 5, and then after that, you square it. And guess what? Yeah, you're right. You do get 25. And so I'm going to put a positive 25 right here. And again, I got to balance it out. So then I put a minus 25 on the other side of that round bracket. So now again, I can rewrite that part in round brackets as what they call a binomial square. That's why it's called completing the square. Again, I'm going to have an x here. Can somebody tell me what's going to be in brackets here? What's going to finish it off?
X plus 5.
Sorry?
X plus 5.
X plus 5. Again, half of that 10. Half of positive 10 is positive 5. There we go. And then again, we have the leftover stuff. So I got this minus 25 minus 10, which gives us a minus 35. And there we go. It is in vertex form. All right, now, time to step it up. All right, so here we go. Next one, example 5 here, is I'm going to now convert y equals 3x squared minus 12x plus 24 to vertex form. Now, I just said that I was going to step it up here. Can somebody tell me what is the difference between this one and the first 3 we just did? There is a difference.
We have an a value now.
Well, we had an a value before. It was 1. But this time, yeah, you're right. The a value is not 1. So here's what we got to do. A little bit of a change. I got this 3 in front of the x squared. What I'm going to do now is 2 extra steps. One at the start and one at the end. I'm going to take the 3 out. complete the square, put the 3 back in. So the extra step is taking the 3 out at the start, and at the end, putting it back in. There's your second step, a second extra step. Now, what I mean by taking the 3 out is I'm going to factor out a 3, which means I'm going to divide every single term by 3. So I'm taking the 3 out, and so 3 divided by 3, well, that's 1, so I'm going to have just an x squared here. Negative 12x divided by 3. Negative 12 divided by 3 is negative 4, and then I'm going to have the x. And then I take that positive 24 and divide it by 3, and I get an 8. So there we go. I just took out the 3. Again, means I divided every single term by 3. Now, inside these square brackets here, I'm going to complete the square. All right, so I got y equals 3. Just going to forget about it for now. So inside these square brackets, I'm going to do exactly what I was doing in the first 3 examples. All right, so I'm going to, in round brackets here, put x squared minus 4x. Again, 8 is not going to be my magic number. So I'm going to put it over here on the side. All right, so what I have to do is figure out what my number is that I need. I'm going to put it right there, but I'm just dealing with inside the round brackets here. Can somebody tell me what that number will be? What number will I need right here?
4.
4. I take half of negative 4. I get a negative 2. But you know what? Yeah, you're right. If I take negative 2 and I square it, negative times a negative gives you a positive. So yeah, it is going to be a 4. So I put a plus 4 here and then a minus 4 on the outside, again, to balance it out, because I just want to change the way it looks. So I'm going to change the equation. All right, so now I've completed the square. So I'm going to rewrite this now. I got y equals, again, that 3, square brackets. And now inside the square brackets, I've completed the square. So again, I'm going to have an x here. All right. In these round brackets here, I take half of negative 4. It's going to be an x minus 2 there in square brackets. All right, or in round brackets, sorry. And then over here, I got this leftover stuff. So I got my minus 4 plus my 8. Well, I lose 4, I gain 8. I'm at plus 4. Now the square has been completed. So here's that second extra step. I'm putting the 3 back. So before, to take the 3 out, I divided every term by 3. To put it back in, I'm going to multiply every term by 3. So a little rainbow rule here. I'm going to take 3 times that whole thing, and then I'm going to do 3 times the positive 4. And so, well, y equals 3 times that whole thing. I'm just going to write it like that. 3 times that whole thing. And then the second part is I'm going to take 3 times the positive 4, which gives me a positive 12. And so now it is in vertex form. Y equals 3 times x minus 2 squared plus 12. There's my A, there's my H, and there's my K. All right. So again, 2 extra steps. Taking the number out in front of the x squared and then putting it back in. All right, let's try a couple of those. All right, so here we go. Example number 6. This time I got y equals negative 2x squared minus 12x plus 10. There we go. So once again, I got a negative 2 in front of the x squared. It's not a 1. So I'm going to have to take the negative 2 out, first step, complete the square, put it back in. All right, so again, by taking the negative 2 out, that means I am factoring out a negative 2 from every term. In other words, the saying is I'm going to divide every term by negative 2. All right, so I get rid of this negative 2. That's the whole point of what I'm doing here. I divide negative 2 by negative 2. I get a 1 here. All right, that's what we want. Then I take my next term here, negative 12x. I divide it by negative 2. Well, negative 12 divided by negative 2 is a positive 6, and this is my x term here. Then I take 10 and I divide it by negative 2. I get a -5. All right, so there, I've taken the -2 out. It's time to complete the square. All right, so I get this -2 on the outside. Again, in my round brackets, I got x squared plus 6x. All right, I need my magic number there. And then I got this -5 that is not going to work for me. All right, so what number do I need there to complete the square as it will be?
9.
9. Half of 6 is 3. Square it, you do get a 9. So I got a +9 here, and then a -9 on the outside to balance things out. All right, so I got my magic number there. All right, so now I'm going to rewrite this. So I got -2. And then I got my round brackets. And then a number afterwards. All right, so if I have completed the square, what is going to be in my round brackets here?
3.
Sorry?
3.
3? Wow, close. You're right, there is going to be a 3 there, but don't forget about my x. So an x plus 3. All right, and then again, I got my leftover stuff here. So a -9 minus 5 is a -14. There, now the square's been completed. So now my next part, put the -2 back. Rainbow rule, -2 times that big thing, and then -2 times -14. All right, so we get y equals, again, -2 times that whole thing. I'm just going to write it like that, -2 times that whole thing. All right, so there's my first part, and then the second part, -2 times -14, negative times a negative. Gives us a positive, and we get a +28. So again, there's my A, there's my H, there's my K. It is in vertex form. All right, last one. One more of these. All right, so here we go, example 7. And this time we're going to convert, which one we got here? Y equals 2x squared plus 16x minus 13. All right, so again, we have a quadratic in standard form. We don't have a 1 in front of our x squared. So again, I'm going to have to factor out that 2. All right, so I got y equals 2, and then in square brackets. Well, 2x squared divided by 2. Again, that's just going to give me the x squared. That's the whole point. All right, then I have 16x divided by 2. Well, 16 divided by 2 is 8, so then we have an 8x. And then -13 divided by 2. Negative divided by positive is going to be negative. Then we're going to get a decimal this time. And -13 divided by 2 is going to be -6.5. So it is possible to get decimals. All right, you're going to see that more. All right, now we're going to complete the square inside those square brackets. So I got y equals 2. Again, in round brackets, I'm going to put my x squared plus 8x. All right, my magic number there is not going to be -6.5. So I'll put that over here at the end. There we go. All right, so can somebody tell me what my magic number is going to be that I need?
16.
16. Half of 8 is 4. 4 squared, there's your 16. So I got a +16 there and a -16 to balance it out. Again, if you're wondering, this one's always going to be plus, this one's always going to be minus. You always get that question. All right, and so now I can rewrite this because I've got my magic number in there. I've completed the square, if you will. All right, so again, inside here, I'm going to have an x there. The number I have right here is going to be what?
+4.
+4. Take half of that 8. There we go. All right, and then again, I got this leftover stuff. I lose 16, I lose 6.5. So I lose $16, I lose 6.5. I believe I'm down 22.50. All right. The square has been completed. Now our last step is let's put that 2 back in. Again, doing the rainbow rule where I take my 2, I times that whole thing, and then I take my 2, and I'm going to times it by negative 22.5. All right, so I get y equals 2 times that whole thing, and then 2 times negative 22.5, so positive times a negative is going to give me a negative, and I believe we get negative 45. And there we go. So again, we have our A, our H, and our K. It is in vertex form. Again, we're going to need this skill big time at 10:30 because the first step of what we're going to be doing at 10:30 is complete the square. So make sure in the next hour, I believe, next hour, that you know how to complete the square because that is essential for 10:30. All righty. Let's just stop.
All right.